Hi, good afternoon. I'm Keerthana Govindarazan. I thought I'll explain a little about me before we begin. So I did my bachelor's in architecture in Southern India, then the master specialisé program designed by data in Paris at École des Beaux Paris Tech. Following that, I went on to work as a user experience designer in India, creating virtual reality and augmented reality experiences for interactive marketing. I also hold a Master of Science in Psychology. This research project that I'll be explaining today was done as part of the Design by Data program. So it gave me an opportunity to explore and contribute to my passion fields, neuroscience and architecture, and see how the two could come together for designers who want to use some form of data set related to behavior to help shape spaces. I feel it's a very broad and a humongous project, which I have named Mindscape. And it starts with this article titled Web-Based VR for Behavior Analysis of Architectural Designs, which focuses on developing and testing a prototype. So that's my abstract over there. And just an overview, an image that gives the overview of the proposed idea. So virtual reality and its various applications will be listed before WebVR and its advantages are discussed. The WebVR prototype is introduced, the software the prototype consists of and how it works as a behavior research tool is explained. Once the prototype is covered in depth, an experiment conducted with it is reviewed along with the inference and the limitations of the study. So now let's get started. So the first place to start naturally was to look at ways to present the stimuli, the visual stimuli of the unbuilt architectural design prototype to the test subjects whose response could be captured. So currently, virtual reality is used to visualize building information model to communicate between teams on construction projects, and even to convey architectural forms and spaces to non-architects. And it conveys better than traditional 2D drawings. And VR was used as a participatory design tool in a hospital interior design project to take into account users' needs. And it's being used in design studios as well to understand spatial proportions, to help students understand spatial proportions. This one particular study done in 2012 established that human behavior and physiological response could be simultaneously recorded using sophisticated KVR, built with walls and everything, and biosensors to help create healthy environments. So this research explores using WebVR to be able to do something similar. It introduces the idea of web-based VR as a behavior research tool. So what is WebVR? It is nothing but an immersive virtual experience that can be accessed as web pages with a head-mounted display that can hold the mobile phones in place. Being on the web, it comes with a few advantages. The hardware requirements of a web-based VR experience are minimal. A cost-effective headset, an everyday web browser, and smartphone will get the job done. And there is no need for handheld controllers to navigate in the virtual space as well. To share online, which means worldwide instant access and quick feedback, and large data sets. If it can be shared online, it can be shared to a large group of people that can help figure out the direction of a public project maybe. And then web analytics and data possibilities. So the clicks on the web page could be tracked to know where the users are moving around in the experience. With the growing popularity of fitness trackers and smart wearables in the consumer market, like health data like heart rate could also be amassed to inform the emotional reaction of users. So these are just advantages that you could see plainly. Given all these advantages, for WebVR to truly work, I had to sift through various options to produce the virtual reality stimuli. So to model the VR scene, I chose software close to the architecture world. Like Rhino 3D is a 3D modeling software widely used in architecture community. And Grasshopper is also is a popular visual programming environment that runs within Rhino. And I came across this plugin for Grasshopper that is used to generate the web VR experience. This plugin basically helps convert the 3D model or the Rhino file into a HTML file that can just be uploaded to the web. So if you have a website, and you can just upload your 3D model without any trouble. So these were the software systems that I chose. And then to collect the behavioral data from the experience, I took the help of the company called Numena in Barcelona. So with the permission and assistance of Numena, the user tracking app it was in its development stage, was used to study as part of the prototype. So it's an API that was built on Node.js. So this system of software was chosen as it takes advantage of an architect's general technical capacity, especially parametric architects, instead of using external platforms that might be unfamiliar or require additional skills. So this system of prototype tries to serve the broader vision of the project, which is illustrated in this image. The spatial mockup is experienced in the web VR by the user, and then the spatiotemporal data of users is recorded. And this helps architects to infer their designs, which when expanded to a pipeline incorporating the software, it looks like this. So the image depicts the production pipeline of the prototype and its implementation as a behavior analysis tool. So the prototype is defined in three stages. Stage one involves producing the web VR experience. So the building to be visualized in web VR is modeled in Rhino 3D, or it could be imported to Rhino 3D. So this acts as the input for the plugin VR Edge, which runs in Grasshopper. And then I just simply followed the Grasshopper code from VR Edge's documentation. And then I was able to procure a HTML file, which I could later share it through the web to the user. So the stage two tracks and collects users' spatiotemporal data. So users' movement data within the web experience is collected using a tracking app, which I explained in the previous slide. So the tracking app records the coordinates of the points that are clicked on the screen in real time, along with the timestamp of the click in a database manager. So this provides information on where a person moves within the visualized architectural space and how long they spend in each location. So, So the stage three visualizes and analyzes the data collected to assist in the design process. It consists of position coordinates, a unique creator ID, and timestamp of each click, which I have pictures of later. So it is then parsed and visualized using Grasshopper again. So the next few slides discuss how these three stages of prototype framework were applied to an experiment. So the demonstration of the prototype by way of experiment had three simple objectives: to study the feasibility of the framework as a behavior research tool, to verify the accuracy of data that was collected of people's movement, and to check the user friendliness of the prototype. So if the KVR and other sophisticated VR is considered, it's behind labs and it's not accessible for all. So I wanted this to be something that could begin to let a lot of people try to use behavior data sets in their design. So this is stage one of the experiment, which involves setting up a scene for the experiment. So this is the design of the scene, basically, that the users will walk through later. So the scene used for the experiment was designed like a museum experience and contained three small islands. So these are the islands. and they were connected through a pathway. Each island contained 3 rooms housing identical, trying to make it geometrically intriguing objects to observe, as you can see depicted here in the concept plan. So this is just a rough layout of it. A side note here, the scene was designed for studying pattern 110 from Christopher Alexander's book, Pattern Language, about main entrances, with the aim of comparing the observed behavior of the virtual user against an expected behavior. So this part isn't explained further as it is beyond the scope of this paper. So I will just explain the use of the prototype basically demonstrated. So this is the actual plan, an isometric view of the scene given to the participants. So to talk a little bit about the scene and the navigation process inside. So VR Edge produces a VR scene that can be navigated by way of teleportation. So transfers the floor of the model into a grid of boxes. So all of these are VR boxes. So you can see little difference in the boxes here due to the color gradient. And that's why the color gradient was chosen for the floor. So each of which acts as a point in the scene that the user can move to. So they can travel to each of these boxes. The VR scene comes with a circular cursor pinned to the center of the screen. This cursor triggers a click action when made to hover long enough on a box on the floor. So if it touches the box raises, and that's where you will jump to. So from point A to point B. So it's called the teleportation method of locomotion in a virtual space. So after having designed the scene, the next step is the experiment itself. So a set of 10 users from varying backgrounds and ages ranging from 20 to 45 participated in the study. The experiment was conducted with each participant individually for close observation. So the tutorial for VR Edge this was just the tutorial, and I've put screenshots of it here. So I just followed these and had some trial and error to figure out the scale of the project and everything. So that was done, and the scene is loaded on the smartphone of each participant who's explained how the navigation works and what the scene is about. The phone is placed in the HMD. So this was the HMD I used. And the user begins the experience. So that's how it starts. So the VR scene was hosted on a laptop. My laptop was basically the server to let me engage with the users one-on-one. The image shows the command prompt running the tracking app on the laptop. The start time and end time of the experience is noted for each participant along with their unique user ID. You can see these are the unique user IDs, and those were the number of clicks they're making. So this shows where the data is stored. This one, it's just a screenshot of RoboMongo. It's a database organizer. So this shows that, and then this image is a screenshot of the JSON data collected. So this is the final file that you get as data. So you can see the user ID here, like creator ID here, the coordinates of each location. So the X, Y, and Z, they move in the space and the time they made that move. So this slide just showed the code I used to get the JSON, basically the data, into Grasshopper and try to visualize it, so it would superimpose lines of where people moved on the plan. And not only that, it was used to calculate the total number of clicks, seconds spent at each location. So other things that could be calculated from this data. So here is a sample of data that can be visualized. The circles denote the clicks here. So the user started here, the green begins is where they start. So the circles are the clicks, and the lines show the chronological order in which they click through and then finished over here. The user has moved from, basically you could see he's moved from island 1 over here and then come back to the middle before they said they were done with the experience. And this one, it's the same user, it's the same movement pattern. It just shows the time that they spent at each location. So I think they got a little while to get started, and they spent a while looking at the objects here, and it shows that they spent more time looking at the objects in this island. So this is just a sample of data that was collected and what was visualized. No inference on the behavior was made, at least it's not part of this experiment. So this image displays all the clicks made by the users who experienced the scene. Like, these are clicks of all 10 participants. It shows the most visited rooms in each island, all 10 users put together. So you could see a lot of people visited this place or over here, and nobody went over here. So you could get a general idea of the movement pattern, how people use the entire space. And you could also, like I was saying with Grasshopper, you could get other details that would make sense to a project, like how much time do they spend, number of clicks to navigate, so maximum time spent per click, so other things that would make sense for a project. So after going through the 3 stages of the prototype for the experiment, these were the observations that were made. So the feasibility, so it's the process to create the VR experiment was seamless, as it was easy to use the VR Edge plugin. And it was just a straightforward process to create the VR experience itself. So data accuracy, so there were accidental clicks that were made when we were trying to insert the phone into the HMD. Like, you would load the experiment on the phone and then put it on the HMD. So those accidental clicks had to be, we have to say, okay, stop, now this is the start time. And then we have to cull the clicks made before the start time and note down the end time, and make the cull after the end time as well. So this is the period they experienced, and those are the only clicks that you consider for the data. So that was about data accuracy. And for user feedback, so without prior VR exposure, all the people were able to handle the VR experience following simple explanations. So there's, like, you could say there's a widespread applicability of such a tool, as people of varying ages and with no prior VR experience, like even first-time users were comfortable with the proposed VR system, and they were, with just a small explanation, they were able to do it at the first time. The limitations, I'm just listing out the limitations I observed while working with this prototype. So VR Edge produces just raw models. I could not add material or texture or lights to the environment. And it is a passive VR environment where I cannot interact with the objects around. It is a hyper simplified version, given a lot of things are just like clay model, or you can add colors. And as the experiment was conducted, the erroneous clicks really did, they were difficult to notice in the beginning and then start culling out. But without an alternate data cleansing strategy to deal with the deliverability of the prototype to a large scale is severely limited. And one more thing that I observed was VR navigation is cursor controlled and does not mimic the way humans interact in the physical world. So I think more work is needed to assess if behavior in VR and web VR especially, and this form of VR, is similar to that in the physical world. So to conclude, the potential of web-based VR is explored in this article. A set of software were chosen, and then data was collected with 10 participants. The position data seems reliable except for the erroneous clicks. And the experiment shows the kind of data that can be gathered and visualized to make sense of the user's experience during the design phase. So it gives a leg up for the web VR to be explored as a behavior research tool. So moving forward, I would say the procedure to collect and visualize data. Right now, I was using my laptop, so it could be streamlined better to be able to share it with a lot of people, and that the data could be made richer with emotional data and rotation of people where they're looking at, etc. And I would just leave this quote here for you to read if we have time left. I think I'm done.
Thank you very much for your presentation. It's very interesting. And thank you also for keeping the time. It's perfect timing.
Should I stop sharing screen or?
Oh, no, you can keep sharing because
Okay.
maybe the questions will need you to share another slide.
Okay, got it.
So does someone have a question? You can whether ask by using your microphone or just send your question in the chat if you're more comfortable with this.
May I start with a question? I have a question about the user feedback.
Mm-hmm.
I want to know some precision if it is just a spatial position, and if so, how do you, I don't know, how do you get some quality feedback? I mean, the user can move towards a direction for various reasons. It can be for curiosity, for a desire, maybe you just need to clarify what he's seeing. And the question behind is, how do you think a designer can do, what can he do with this data? Or maybe it's just about an implementation of the method you're proposing now that could be integrated. I don't know, just.
So the idea was to just introduce and explore this web VR to see if it's even viable for someone to do it. So I did, during the experiment, conduct a survey where I said, you know, do you remember going here, or, you know, why did you see it? But they didn't seem to know why they did what they did. Like it wasn't very objective. They were just like, no, I just had a feeling to move there, and they didn't have purpose at times. Some people were just moving too fast and quick and exploring the same place over and over. Some place it was more guided for some people, like it went from one place, from island to island to island. So I have not gone into the subjective dealing of the data. And I'm hoping if this system becomes more robust, and as neuroscience and architecture figure out more you know, principles that make sense, basically adapt behavior to, I mean, data sets on behavior to design process. So this is just, I've left it open-ended for now. So hoping for emotional data and other things to, you know, be improved in a while for it to be applied.
Okay.
Thank you. Thank you very much. We also have a question in the chat. So based on, asked by Rizette, based on the experience, how in the future will you measure the user emotion? So this is, yeah.
So the idea, it hasn't been tested. It's just a area that I wanted to look at. If I basically want to take this up as a PhD at some point and maybe look at other emotional data. So basically the consensus is that the fitness trackers and a lot of things are getting more accurate to track, you know, user heart rate or skin conductivity or the other things. So I was hoping I will be able to tap that to address emotional data of the users. Yes.
I have a question. I was thinking about it now. I think now they develop more and more VR headsets with eye tracking. And I think they're even implementing some that could capture EEG as well.
Yes.
So I was wondering if that was something that you were thinking about for future work.
Yes, I wanted to consider eye tracking and like you said, EEG, they were the most important biofeedback that I considered in the beginning. But then I also wanted to explore something that, you know, people could start using to some extent, you know, make sense of the data that they get. Like, even if it's a museum, like how long do they spend looking at one object versus the other one? So yeah, it's a very vast topic, and these are in the cards to explore. So yeah, I will look into them.
And I just wanted to add a thank you for the presentation. I think it's amazing to start thinking about like the patterns from Alexander, questioning it with new data that we can get. It's a way to kind of verify such patterns.
So it was try to address the question of if behavior, based on Alexander's pattern, there is an expected behavior if you build it certain way, right? So if I do the same design in virtual reality, will it mimic the same behavior response or not, was the idea. But everybody could design it a certain way, the same principle. So there is again a vast topic over there.
Actually, I also have a question. So, okay, the topic here and the scope of the study is to test a prototype. But did you already notice a difference between the expected behavior and what you actually observed?
No, I actually, it was the same. I expected a few entrances to be chosen. Like I knew a few rooms will be visited more than the others. So collectively, that did make sense. Like I thought that's when I will explain the Alexander, like as maybe I could write another paper explaining the behavior analysis part of it.
Okay.
So yes, it didn't deviate according to from what I saw with the participants that I explored.
Thank you. We have another question in the chat. Keerthana mentioned, it's also by Louisette. Keerthana mentions that the users were attracted to go there and not elsewhere, as if they were attracted to do so. I believe this is already a behavioral data to be tracked. It's more a comment. Any thoughts?
Yes, I mean, basically it was that like when you conduct post-occupancy evaluation, also there is the problem that users are not objective. They're not very aware of why they do what they do. So that's why neuroscience and architecture, they try to get more objective feedback of behavior, emotions. So you could maybe make sense even if the user doesn't know it. So that's where we are going, I feel, with neuroscience and architecture.